Last bit of housekeeping for those in the room. Does anyone have any objections to their photo being taken? I can start. Have you got audio coming through? Marvelous. Okay. So, first of all, an apology. Normally, these things are opened and there are speakers who are such luminaries as DevOps Engineer of the Year and stuff, keynote speakers at various events, and sadly tonight you've got me, so you're very shortchanged there. My name's Andy Tebb. I look after our product engineering labs in the UK. In Global Logic, we're very lucky. We make such products as the software inside a cochlear implant that allows people to hear. We make the dashboards in a Polestar car. The software inside an Amazon Ring doorbell, that's us. If you're making a payment anywhere in the world, odds are probably 50% that it's going through software we make. We basically make a lot of software, a lot of product that impacts people's lives positively. But fundamentally, that's underpinned by engineering. That's underpinned by some really good tooling. And it's more than that, underpinned by the people with diverse and interesting views that allow us to make products that are really good in people's hands. Okay? And because of that, for a long time, we've thought that tech should be accessible to everyone, the latest tools, latest toys should be accessible to everyone, and that's why we sponsor the DevOps Playground. The DevOps Playground is its own thing, but it's all about making tech accessible to anyone who wants to try and use it. So tonight, you'll be incredibly lucky in that you'll have a talk regarding Terraform, and in the context of Minecraft, and the ability to have some hands-on exercises. I think our youngest participant tonight online is 8 years old. I assume he's here because of the Terraform. You know, multi-cloud is big with the kids. So, but if the demo fails or there's any problems with your hands-on, try and keep the language clean because the video is going out, okay? So, I think we're all looking forward to tonight. It should be an interesting event. But at that point, I'll hand over to your speaker for tonight, who I believe is Mr. Salami. Excellent. Have a great night, mate. Do well.
Thank you.
No worries.
My bad. Spare me. Hello? Mic check. Awesome. Am I ready to go? Say again? All right. Hi, everyone. Welcome to DevOps Playground in London. Today, I'm going to introduce you to Terraform, as in Hashiconf Terraform. And my name is Wale Salami. So I'm going to walk you through what infrastructure as a code is and what Terraform's goal is. Also, some of the Terraform's functionality, which is the state, providers, resources, and modules. The reason I chose those functionality is because you will be working mostly with those today with your with the Minecraft. So it's best for you to know some of the resources you'll be working with, basically. So what is infrastructure as code? So infrastructure as code is the managing and provisioning of infrastructure through code instead of through manual process. This means in case of you wanting to provision any infrastructure online, such as AWS, and you want to go on there and create VM. So you normally go into AWS console and do that, which is long manual process, which you could forget certain parts to it. So infrastructure as code kind of helps you with that, as you can just use your code to provision infrastructure. And that brings me to Terraform's goal. So Terraform's goal is to have a unified workflow using infrastructure as code, and to iterate over infrastructure safely, and that is capable of provisioning anything, anywhere. So as you can see in the graph below, that you as an engineer, you would write your code, and then you would do a plan, Terraform plan, and that would then show you what will be provisioned. And if you're happy with it, then you can do Terraform apply, and the Terraform apply can then be applied to any of those platforms that you can see next, which is AWS, Google, Azure, whatever you want it to be. I mean, mostly everything is supported, as Terraform uses API to work, basically. So yeah. And then now we're going to move on to state. So Terraform state. What is Terraform state? So this is how Terraform knows what it's managing, basically. So if you provision 2 VMs, then those 2 VMs you'll find the state. You'll find them in your state file. In your case today, you will find your state file on your VM, which is terraform.tfstate. In there, you will be able to, you can customize the state file actually, but it's not recommended to do so, because if you're not sure what you're doing, then you could mess up what Terraform is managing, which means if you were to run Terraform plan again, it might assume that it's not managing something that's already managing, so you might get errors. So yeah, you're recommended not to amend the Terraform state file, but you can have a look at it. So that's that. Now, you're also going to work with providers today. What providers are? There are like plugins, which Terraform uses to communicate with the tool that you're trying to talk with. As in, today, you're going to be communicating with Minecraft. So therefore, you're going to be using the Minecraft provider. And inside the provider block, you would have configurations. In this case, for the Minecraft, address and password are mandatory. That's why you have to put them in there. Whereas some other providers don't have any mandatory configs that you need to put in, but in this case you do. And yeah, here's a list of other providers that you can use. There's more. You can go, when you go to the registry.terraform.io, browse providers. There you'll find all the providers that Hashiconf Terraform supports. Now, we're going to move on to resources. So with resource, whenever you see a resource block, that's how Terraform is creating whatever resource you would like. So in this case, Minecraft is the provider, and block is the function, I guess, that it's trying to use. In this case, we're going to create a block. So if it was AWS, you would find AWS underscore wherever resource you're trying to talk to, and then you give it a name. In this case, the identifier here is called stone. So overall, the unique identifier will be called Minecraft underscore block.stone. That's how Terraform will know this resource in their state file as well. That's how you find it in there. And then, as you can see here, you have some configurations that you need to provide here, which is the type of material, and then the position as well. And then we also have modules. What are modules? Modules are portable Terraform configurations, packages, and they allow separation of concerns and responsibilities among teams. Modules are just Terraform configurations inside folders. So as you can see, something like this here, where we have the resource block. If you were to put this now inside the folder, then any other resource can also reference this as a module, basically, which I'm going to show you in a minute. So modules are like programming languages, language classes, which means they are reusable. In this case, these are all the ways that you can do module declarations. So the first part is the local paths, which you're going to be working with today as well, where you have your module locally on your VM. So you have the / and then the name of your module, in this case called cubicle. And the count is it's going to create 5 cubicles, basically. And you also have GitHub and Bitbucket, so you can use those as your source for module as well. You also have the Terraform registry, where you have Hashiconf and then the name of the module. And then lastly, you can also use the Terraform Cloud registry, or if you are hosting your Terraform Enterprise on your environment, in wherever you work in. So that would then have whatever the name of the UI that you use to go onto Terraform. That's what the source would be here as well. And that will be called the private registry. So that's it in terms of most of the resources you're going to be working on now. So the next part is the lab session, which Patrick is going to walk you through. If you have any questions, please feel free to ask, and we'll try and answer them. Thank you. Yeah.
Just a quick switcheroo and we're good to go. Thank you. Okay, if you want to admire my wallpaper, by all means. Okay. So, I'll be leading the hands-on section, and before we start, just want to make sure that everyone is on the same page. So first of all, if everyone has a Wi-Fi, if not, please scream for help. There will be people around to help with that. And once you get through the struggle of getting a Wi-Fi, there is the little website called lab.devopsplayground.org. DevOps Playground as a one word, lab.devopsplayground.org. And it should look more or less like this. You can see that the UI design was made by a DevOps person. And if you type your meetup username, so in my case it will be Patrick Pilecki, you should see your credentials shortly. This is the meetup username you show to other people, so it's not your email address. It's what other people can see on your meetup profile. And I know how hectic it sounds, but this is the only data we can actually get about you from meetup in a programmatic way. So hence, that's what you need to type. If you, by any chance, joined internal invites, your name and a surname with capital letters and space in between. It is case sensitive and it should work. If it doesn't work for someone, please just ask around. It's lab.devopsplayground.org. So just so we know that everyone got their stuff. Oh, that's interesting. Got Trusty Panda this time. Cool. Once you manage to get this output, something in those lines, what will be different in your case will be probably a mood of your panda. So you might be funny, angry. I'm a trusty panda. And then all those DNS records should point you to, respectively, IDE, terminal, and the Minecraft map. So I'm going to close the tabs to the right, which I opened before, because that was someone else's panda. Oh, apologies. I'll keep looking on the projector while I've got a screen next to me. So ideally, if you would open in a new tab the terminal in one, that's the code editor, then the terminal. The password to your terminal will be capital M with capital M Minecraft 23. That should do the job. If you prefer, you can SSH using this DNS record and Playground as a user. It's going to work as well. We assume that you can't SSH for some strange reason, hence the browser. And the very last one should be a Minecraft map. And it should look more or less like this. You can zoom it in, and on the side you have different views. And I don't know how far we shared it, but there's also a repository with the instructions. It will be on our GitHub, on DevOps Playground, GitHub, and it's called Terraform x Minecraft. It will kind of, in the very first step, it will have more or less what I just said, and the link to the lab step by step. It should be self-explanatory, so hopefully, even without me, as bad as it sounds, you should be able to get along and have no problems. On that little instance you can log in. I made a few aliases for the helper commands. So what we will be doing, we're going to use a Terraform, which is infrastructure as a code tool, to manage the infrastructure, which is a big word, in Minecraft, which is a video game, which I've never played before, but apart from using Terraform. There might be some delay in the rendering. As you can see on my map, I have a little guy there. So there's a Barnaby in the corner who's actually playing Minecraft here and getting paid for that, which is a pretty good job. And yep.
We're talking about that. You're on a different server than the DevOps. Can you type the op command when you get on?
Not sure what you mean.
You're on a different server than the DevOps, so he doesn't have that. So can you type that command?
I'm on a different server. Okay, cool. Yeah. Oh, now I know what you mean. Sorry. Yeah, cool. Will do. Yeah, I was a different panda before, so I need to make a Barnaby an admin on this server, and he will be able to show in real time what's actually happening. What we see here, it's a little clunky, and it might take time to refresh. So I made a few commands you can use to reforce rendering of that word. You can see some command, you can see the logs. Yeah, it's not perfect, but if another way would be to give every single one of you a license, and we didn't have a budget for that, so this is what we can get for free. While you're setting up, and I will hope that if you still do, you will shout for help. I quickly just need to get a Barnaby permissions to do what he wants on my server. So, and I don't remember what that was. So just give me 1 second. I saved it somewhere as an alias. There you go. You don't really need to follow what I'm doing right now, but. So it was OA and his nickname, right? OP, cool. You good? Awesome. Cool. If you happen to have a Minecraft license, go ahead, feel free to log into that server, and you can see all the stuff we're doing happening in the real time without delay. I'll try to make this workshop flowing enough that I'll tell you to don't think what you're doing, apply, and I'll tell later, so you can see actually what happens and to tackle this issue of being cheap. Cool. Everyone is on the same page. You got your README, hopefully, your credentials, and all the stuff I asked you to have. I'll close everything which is not needed. I'll trust the authors, but you don't have to. So that would be if you want to drag it between on your two screen, split it on the screen, whatever works for you. I'll try to go with one window because I know not everyone has two screens on their hand. So the very first step, I'm going to clear this terminal just so we start with a clean slate. So hopefully you're logged into that little virtual machine. I hope that's visible enough. Cool. And the very first thing I want you to do before we start is to copy this command and paste it in your terminal. CD stands for change directory. If you haven't used Linux before, we're just getting to the right place to execute and play around with stuff. Nothing special about it. And before I get any further, like you've heard a lot about Terraform from Wale. It's a great tool. Infrastructure as a code is a great philosophy to approach your infrastructure, especially in the cloud, when you can actually do it in opposed to the on-prem when your infrastructure as a code is call mark to put another disk into the rack. Now we can actually leverage versioning the code of our infrastructure and use it properly, use it within the pipelines and so on. We're going to use it in the probably most silly way today, because I don't think the real use cases of managing Minecraft through Terraform are present, but it's not about that. It's about how you use infrastructure as a code in general. The principles are the same, and why would you use it in the first place? I hope I will build through the Terraform functionality, the limited scope of its functionality, and make the case why it's actually cool to use infrastructure as a code in opposed to hand crank stuff and do it manually. So assuming that you are in the right directory, I'm going to go to my code editor very shortly. But before I'm going to do that, I'm going to copy the content of this little box. That will be our first file. So what I'm going to do, I'm just going to open, oh, well, this is zoomed in a little too much. In this directory, I'm just going to create new file. You can do it through terminal. Whatever is your best way of creating files, go for it. And I'm going to call it terraform.tf. How is it actually called? It doesn't really matter as long as it has .tf. If you call it banana, it will work. It's fine. Generally, I'm calling it Terraform because it includes the Terraform block, and you will see more of that as we go through the lab. So that's the structure you're going to usually see in the Terraform code repositories. There will be some Terraform files, some provider files, some main files, some variables file, and we're going to touch on most of them today. It should be auto-saved. You can do Command S, Control S. I think it will save it automatically for you. And after that, I'm going to copy yet another block of code, the provider block, and I'm going to create another file called provider.tf. Again, doesn't matter. The provider doesn't matter as long as it's a Terraform file within this directory. And what I'm doing here, I'm defining a provider, and this is probably an important part to stop for a second. So, provider could be Minecraft, could be AWS, could be Azure, could be Kubernetes. We're going to download that provider in a minute. I'll show you how it actually looks, but it's basically an executable which has mapping to all the possible operations you can do against whatever that provider is for using the Terraform code. So you will see, for instance, that if AWS is publishing a new service, you will need to update your Terraform provider because it doesn't have the API calls necessary to create or manage those resources. In this case, it's as simple as it gets. We're going to use the provider. We're going to provide the Minecraft server address. There's pretty good with networking. You can recognize the feedback loop here. Yes, we're going to execute the commands against the same server. It could be a remote one for the performance and efficiency. We're going to do it all in one instance. And I'm providing a password panda time. You all have the same password. If you write the Terraform for your production code, don't do that. Absolutely don't do that. We can there's a million better ways of providing credentials than that, and we're going to cover some of them. Terraform integrates pretty well with any secrets management engines as well. So yeah, but I hope I don't have to say that one more time, but don't pass the password as a string unless there is no blast radius and you're just having fun, which is the case for us. So we got those two files, provider.tf and terraform.tf. And the very first thing we need to do is to initialize this code configuration. So on the servers you should have Terraform installed, and if you not sure about it, you can just type Terraform and see what happens. So like, this is my way of testing software a lot of times. Just press enter and see what happens. It looks like the Terraform is installed. There are some commands you can use. I call that a success, and I'll go straight to initializing this configuration. So the Terraform did some stuff for us. And again, the fact that I'm in this directory, not any other, is crucial here, because it just reads the files which has in the current context. See, what do I need to do with that? Do I need to do something? Everything is okay. In this case, it needed to download the provider we're going to use. And I think I even in this 2 steps, yeah. So what we can see now, I'm going to clear this terminal again. If we list our files, and I'm going to use ls command, I'm going to add the flag al, so we're going to list also the hidden files. We can see that there is some new stuff here, which we haven't really created. So .terraform is the crucial file, but also .terraform.log. So if I will be nosy and say, like, what that Terraform actually done here? And if I'll just keep going through all those, so you can see, well, there is a Terraform created the hidden directory. It will be a nice separation to store providers in one place. It does have the registry.terraform.io, which will be a default registry for your providers. If you have a bit more elaborate, complex setup, you can host your own providers, write your own providers. James, who's in the back, even had a playground on writing your own providers. So if you need that, that's a possibility. And then what's the developer, provider name, version name, platform. And if I will have a look here, for the Linux users, the big green highlighting, that's an executable. So basically, that's what the Terraform does. If I need a provider for Azure, if I would define it in any Terraform file, it would download the executable for Azure, which would have that mapping of what can I do with Azure. Long story short. So we got our provider initialized. I think I also thought of having a look on that log file. So why not? I'm going to cut it because it's a small file in this case. And it was .terraform.log. It basically has a hash sum of this provider, more or less like what you see with Node.js with dependency management and so on, like a dependency file gets created so we know what we're using and we know we're using the right thing. Cool. Does that make sense so far? I can see some confused faces. Please stop me if it doesn't make sense, if you get stuck, because yeah, I'm here to help. Like I've done this before with mixed results, but I've done this before. Cool. So we got the provider. So our Terraform knows what we're dealing with, how to connect with that part, because we provided it with the password. So now we're going to recreate something, but first resource. See, I prepared a little code block for you here. You might have an idea of what's going to happen here. So you got some material, you got some position. The whole games is about placing blocks now and there. So I'll let it for your imagination, but we probably going to end up with a block. In the README, I suggested again to create another file, main.tf. Again, you could put it all in one. You can organize them like you want. That's the structure you will see described as best practices, and you will see in the most of the Terraform repositories. So, I'm trying to stick with that. And I copied the name of the file instead, but that's fine. So I'm going to paste the contents to the main.tf, and if I remember correctly, then in the next step, I advise you to see what that's actually going to do and apply that plan potentially. So I'm going to just rush through that, and I'm going to click enter twice. There's also a pwd, which will command here, just to make sure that you are in the right place. So I'm just going to clear the terminal again, pwd. You should be here in Terraform x Minecraft directory. And I'm going to quickly go with Terraform plan. And shortly I'm going to do Terraform apply, and I'm going to type yes. And then I'm going to say what I actually have done and why. Cool. Something happened, but let's go back to the first command. So with the Terraform plan, self-explanatory, we tell Terraform, plan what happens if I would like to use the configuration in the current context, hence the pwd before. And Terraform tells us if you would like to apply what we defined here, well, I would see that you're missing a one block on those coordinates with this material. So I would plan to add one block, nothing to change, nothing to destroy. I mean, we just have one block, we're just getting started. After that, the command exited, nothing happened. It might feel pretty useless when you think what happened in the Terraform apply, but there is a good use for the plan command as well. We're going to cover it in a second. When I run Terraform apply, same stuff, but in this case it tells us, okay, if you like what you see, you can say yes, and I'm going to apply that. And I did it right away. As I mentioned before, it might take some time before that magic dot will appear. Hence, I just executed it mindlessly. With the helper command, I have the MC logs, which will be Minecraft logs. I could see that someone actually tried to get on that server and place that block on those coordinates, which I would call a success, and we can have a look if we can actually see it already. I'll zoom it in. Not in my word. So the good way to kind of trigger our rendering is the command render -flat. And if I go back to MC logs, you can see that it started rendering that word again. It takes a minute or two. Works most of the time. Again, we're working on the free stuff here, so not every time is perfect. We can refresh that page, or you can trust me that there is a block here, or I can ask my little elves to show you that block here. Oh, there you go. I didn't even have to ask. So this is actually the server Barnaby is on right now. Yeah, if you could go back to my screen, thanks. Yeah, it's not there yet. It will be in a second. We can move on. We can just let the magic happen in the background. Like I said, it goes through a lot of hoops because we're doing it without the license. So I'm going to move on to touch on a few other points. I mentioned that the plan, it doesn't make sense in this use case, but it is useful. You can save your plan to the file, for instance, and you also have the auto approve flag. And this is like be very careful because there's no time to back out. If you go Terraform auto apply, it will just apply it for you whether you like it or not. A lot of times, if you use the Terraform in a CI/CD tools, Jenkins would be a good example. Like that, you can't really make the Jenkins to type the input while your pipeline is running. So you would save the plan to the file. Then based of what was sent in the file, you would run auto apply as a part of your pipeline. So you already verified what the plan would actually bring. So that would be a common usage of the auto apply. What we've got next, unapplied, cool, render flat. I already went through that. Oh, state, that's a good one. So I'm going to have a look. Yet another look on the map, and still nothing here. Sometimes, like I said, it's a bit irregular, but I'll give it another minute. And yeah, the next part I was about to mention is the Terraform state. So I'm going to clear my terminal again. So we tell the Terraform, okay, we want this configuration to be executed. And the Terraform did it for us, and I say apply, yes. If I would tell to Terraform, plan something, maybe not Terraform, plan something for me like right now, they'll say, well, nothing to do. Because we already applied that configuration, and Terraform knows that it was already applied. How does he know? Or she, or it. So the moment we applied our configuration, yet a new file appeared here, and it's called terraform.tfstate. And this is the state of our configuration now. I'm going to cut it because I know this is a very small state, but be careful with cutting stuff because usually Terraform state might have thousands of lines. So if I will have a look on that state file, it just tells me, okay, we use the certain provider, and we create the certain resources with certain attributes and so on. Very simple in this case. If you would have a bit more complex configuration, let's say you're creating the resources in a cloud, you have virtual machines, load balancers, some security groups, some rules on those load balancers and security groups, you can see how that will grow massively very quickly. In this case, we just execute Terraform from the command line, and our state is stored locally. In, let's say, more serious enterprise scenario, that wouldn't be really a feasible option. So Terraform would support the remote state. You can store your state in one place, so then different developers are executing against the same state file. So it's not going to be the situation when one person creates something, another creates the same stuff, because you execute against the same state. Probably a good example of the remote state, and I'm just going to show you one of the workspaces we're using to create that lab infrastructure, would be Terraform Cloud. So this is the interface of the Terraform Cloud. You can integrate it with your repository and so on, and basically it will execute your Terraform code. If you ever seen the Terraform Enterprise, it looks exactly the same, but from 6 months ago. But if I go to the particular workspace, which will correspond with my code repository, you can see that there is a state file here, very, very long one. There's a lot of stuff created and so on and so on. Thousands of lines just to get your environment ready for today's lab. So it grows in complexity quickly. You can technically import what you already got to the state. So you don't, let's say if you have something you created 10 years ago, no one knows how to touch, and it has to be in that account. Like if you worked in an enterprise environment, you probably came across those problems. You can import that, and then Terraform won't try to remove it or act against that file. And since I waffled for 3 minutes, I'm going to do another refresh on this little page, and maybe the little dot actually appeared in my scenario. Oh, that's extremely annoying. It usually does. So I hope it did for you. I'm going to do one more render and move on to the next bit. Like I said, the dot is there. We're going to get them a bit more complex than the dots, so I don't want to get too excited about this part. And the next bit is also not really right to the executing stuff. Okay, cool. So at this point, we got one resource, and we hard code the parameters of that resource. So we tell it to be a specific material and a specific position of that block. Not the best way to manage stuff, not the best way to version stuff. And if you think that your code might be executed from a different place, also doesn't sound like the best solution. So Terraform has what we call variables. If you did any programming or was close to any coding, probably came across of some form of variables. So I'm going to grab this part, I'm going to copy it, and I'm going to create a variables file. I'm going to call it a variables.tf file. No surprise there. I'm going to paste all that stuff. at this point, this will have absolutely no effect. Or worst case scenario, Terraform will tell us, hey, you got some variables and you're not using them. Do you actually need them? I'm not 100% sure which one, but you can do Terraform, but yeah, nothing changed. I added variables, but I'm not using them anywhere. So the next step will be to refactor that little hard-coded piece of code to actually start using those variables. And I'm going to do it by going to the main TF. I'm going to get everything which I've got here and replace it with a new stuff. It will be a recurring methodology. So I defined some variables. I defined a map of positions, a map called position, which has a default value, which is exactly the same as the hard-coded value. And I have a variable called block material, which will have a material. You can add you can enforce the type of a certain variable. So for instance, if you then share your configuration for someone else to use, you can make sure that they will use the variables in the right way. You can have a defaults on your variables and the descriptions. It is important to make it meaningful and reasonable, because the way the Terraform code is stored, it basically automatically will generate the documentation for you based on those variables. Then we have also outputs variables. So you'll see in the documentation, what can I change in this configuration and what can I see after this configuration is applied in a fancy markdown table. Cool. So hopefully at this point our main.tf file looks like this, and our variables.tf are also more or less like what I've got on my screen. And like I said already, the plan doesn't change anything because we didn't change anything in those variables. We only use the defaults here. But like I mentioned, the Terraform, you can pass the variables to the Terraform from the multiple places. I'm going to refer to the Terraform cloud again because good example. If I go to one of our workspaces in Terraform cloud, I have variables here. So if whatever I had defined in my code will get overridden by whatever is defined here. See, on a different level of where your configuration travels, bad wording, but you can override the variables. So why would that make sense? Let's say we have the same configuration and different tiers of environments. So we got something for dev, we got something for testing environment and for prod environment. Usually our dev environment will have some small computing instances, and we'll aim to limit the cost if we don't really need to incur it. So in this case, we could have the same configuration and just parameterize it for different tiers of environments. They're very, I added the link to the documentation. I think this is about the variables in general. And the one very shortly, I think I added 2 links. No. Cool. I would the Terraform will also get the read environment variables. I would expect that what the link I included there should show which variable will take the priority. Say the Terraform Cloud will have also different tiers, so you can set the global variables, you can set the ones for the workspace. The ultimate winner, so on the very top of where the variables are defined, will be a command line. So in this case, if we execute the Terraform and we'll pass it as a flag, this will take a priority over anything else. If you will run your Terraform Enterprise, Terraform Cloud, you'll probably have no access to even do that, because that will be run by some agent which executes your configuration. So in this case, your Terraform workspace would take the priority. What we can do, we can see if that actually works and if what I'm saying makes any sense. So let's give it a go and just try to execute that plan, passing a different material. So I change the stone to gold. If I hit enter, it actually says, okay, something different here. I would like to change this resource in place for the attribute of this resource from stone to gold. And this is another interesting part of the Terraform, which probably is not best represented by this provider, but most of the major providers work really well in terms of, do I need to actually remove this resource and create it again? Or do I just need to change one of the parameters of this resource? So again, more real life example, let's say we create a virtual machine. All of a sudden our tagging policy changed. I need to change the tags. There's no point of destroying your virtual machine just to change the tag. You can do that as a change in place. So that will be the icon we'll see for that case. If you would change your bootstrap script, for instance, well, you can't get away with that. You need to actually recreate the resource. So there will be a little minus and plus in this case. The Minecraft provider is not really the best with managing those, but if you use AWS, Azure, they do a pretty good job, and they won't force you to recreate the resource when you got a chance to actually change it in place. I'm gonna refresh that page again, and if I'm not gonna see the dot, I'm gonna be very angry, but yeah, there it is. So even in this little, probably the little globe is obstructing it, but the very first dot is there. So we actually made it happen. Apologies for the delay in the view. And we can move on to the next stuff we're gonna do. Okay. So we got one block. The very next bit we're gonna do, I will settle on the plan on changing the material. Let's move on. And what I'm going to do, I'm going to copy this piece, this code block, go back to my main.tf file again. I'm going to just replace it, but it's just adding the second block. So the important thing to see, I got the name of the resource I'm assigning to the resource. It's block 1 and block 2. I can't call the same type of resource with the same name twice. Also, I added a little math expression here to our coordinates variable, so we can mix them up, the variables and expressions, and so on. So what we should see with this configuration, should see a 1 dot and another dot 10 blocks to the right in this particular case. I'm going to apply this with the variable, so I'm going to just grab this line. I'm going to also use the material gold ore, and I think in this case you will see that it didn't really made a great job. So you remember when we were just changing the material for this block before? It tried to change it in place, now it tries to destroy it. So this is something which in using main provider should not happen, because for that block actually it could have been a change in place. Yeah, again, free stuff and a fun project. If you would use a bit something more serious, that should be managed pretty well. I'm going to go with yes and create 2 little gold blocks before I'm going to go further. Again, that went really quickly. I can have a look on my Minecraft server that the blocks were actually added. We got the coordinates here, and I can be ambitious and hope that if I will execute the render flat again, they will appear shortly. Believe me, they will eventually. And cool, we got 2 blocks, 2 golden blocks. So, and in the very next one, I want to make even 5 of them. Okay. Well, basically, I end up with the line. Okay, I'm gonna refresh the map. Oh, happy days! So that went quicker. As I said, like the rendering of this view, it's a bit flaky. Someone spent some evenings to actually make it happen, and I'm really grateful for that. But it's not really super fast. But we've got 2 blocks. We can move on to the next part. I'm going to, again, copy this whole piece, paste it to the main.tf. replacing everything else I had. But you can see that this is getting tedious because I got block 4, block 5. What if I'll have 1,000? That's not really the way to manage my infrastructure. I'm gonna do it anyway. Is that what I wanted to do? Yes. So I'm gonna apply with auto approve for a change because we haven't done that before and you might not trust that it actually works. So you see, I didn't have to say yes, it just went ahead and created the 5 blocks for me. I'll just try to render it again. They might take a minute to appear. I'll have a look on the map again. Yeah, I'll give, oh, there you go. So, fair enough. We built some dots and lines. That doesn't sound exciting, but just to check up before we're going to get further. Are we on in the same place? Does that make sense? Do we have any questions? Can we see the dots? Or a line, yeah. Line and dots. That's cool stuff. That's a beautiful fence, by the way. Thanks a lot, James. So, cool. That we can make the resources, but at this point, when we create each one separately and so on, that doesn't sound really like a DevOps way of doing stuff. I also mentioned the variables. So, if I want my configuration to take any inputs from whoever is executing it or using it in the future, I want to have variables there and make people able to actually change stuff there. But what if I don't? I might be an author of some configuration and I absolutely don't want my, let's say I want to create an S3 bucket for storage. And I want to share it. I made the best S3 bucket you've ever seen. I want to share it with everyone else. But I absolutely don't want any users of my bucket to disable encryption for one reason or another. So in this case, I can use locals. Local works very similar to the variable. I can define objects, maps, strings, integers, and so on. But once the local is defined in our configuration, whoever is then executing it, it can't be overridden. There are some vigorous discussions about where to use locals and where to use variables. I think my simple answer would be, if I don't want people to change it, local. If I want people to change it, variable. And sometimes those can mix up. So you might construct part of your configuration to be, let's say, semi-rigid and give like a little chance for the user to actually change the rest of it. I think we'll have the example shortly. So far, what I do, just define a local. So I define a bunch of locals, but I only included one, and I call it list of blocks. And it might be familiar to the little fence we created. Basically the same stuff. Still doesn't really look handy. But what I'm also doing here, we're going to step up in terms of the resource creation. And instead of create a resource for, let's say, the first element from this, for at least second element and so on, we could use for each, and I'll look for Wale to correct me. I think it will be meta argument. Terraform supports meta arguments, expressions, and functions. And usually when you think it's a function, it's a meta argument, and the other way around. I think for each is a meta expression and for is a function. Doesn't really make sense to me, but you can use like a basic functions, I will stick to that name, to dynamically create your resources or dynamically populate the resources you create with the certain parameters from the input. In this case, I think what I changed, because I was cheeky here, before we were moving on the x-axis, and in this case, we're moving on the z-axis. But if I'll copy and paste this code here, it should make a line like going up instead of right. In this case, I would just paste it to the main.tf, again, replacing everything which was there before. You can probably imagine that at this point, the whole variables are becoming irrelevant, and you're right. I'm going to quickly apply it because we all know how long it takes to actually apply stuff. Well, to apply it doesn't, but to see stuff. And I'll come back to what we've done. Yeah, typing is not my strong suit, as you can see. So Terraform apply, cool. We're gonna destroy 5, add 5. Again, probably not the best handling because one of the blocks will be the same. The one in the starting block 0, 0. So we kind of the delete block to make the same block. Again, this is how the provider is written. Usually, with the major providers, you will handle it in a graceful way. But I'm just going to go yes and make the line in a different direction. And that should appear shortly. I'll follow it with the rendering, but let's not worry too much. Again, I can have a look on the server logs that we actually got our blocks created on the z-axis. Cool. So having locals like that, it's not really much of a step up. So we still got a long list manually populated. At this point, we're going to get to some of the Terraform functions. So I'm going to replace the locals and the list of coordinates. So again, just bear in mind that I think I call it list of blocks here, and there is a part called list of coordinates in this little part. So what I'm doing here, I'm using a set product function, which I think I added documentation here, and I'm using a range function to define an input to the set product. So I'm going to use some variables as well, called width and length. You can probably figure out where I'm going with this. But first things first, so what the range does. If I just provide one thing to the range, which I'm doing in this case, well, could be actually, I will be doing in this case, it will just show me the numbers from this range starting from 0. So that would be the output of the range 3. I could also use start and limit. So it would start from one point and another point. And I could use the step. So you could, for instance, take the range from start to the end, skipping 1, 2, or 3 steps. So I added the links, fairly simple. Like if you ever did any programming, it should make sense. Alongside with that, we've got a set product functions. Set product will take 2 lists and basically combine them in any possible ways. So it will, if you provide, let's say, 2 elements in one list and 5 elements in another, you will have 10 variations of what you can make out of that list. What we would do in terms of our coordinates, so if we would provide boundaries like width and length, I left the height because that's our ground level on the Minecraft map. We will get to that as well. So this would create a list of coordinates. As good as it sounds, as close as it is, that wouldn't be really enough to feed our resource, because what we need the map. So in this case, in the very next step, we're going to use a zip map function. So we're going to take the previously created list of coordinates, then we're going to use a for loop, and each element of that list, which will be a list of coordinates, will have the assigned keys to its values. So it will basically, within those locals, and now I hope it makes sense what I said before. So I did create a certain, let's say, template or a framework. You don't, as a user, when you will use my configuration, you don't need to worry about how do I provide those configuration and so on. All you need to worry about in this case is what's the width and what's the length of what I want to build. I'm going to copy this part to the main.tf. So I'm going to, again, let's say remove everything from main.tf, I'm going to paste the locals with those two list of coordinates and list of blocks. Then I'm going to move on to the variables. I think I went a little too excited with the deleting stuff, but cool. So in variables, cool. I'll leave the block material, because that might be useful, but I'll get rid of the position. So I'll add just those, and I think to the main TF, I got a little too excited. I thought I have it handy to copy, but what I'll need is also the resource itself. So I'm gonna grab that back. So just so we're on the same page, your main.tf should look like this. You have the locals with list of coordinates, set product, blah, 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 and the list of blocks which make the coordinates to the maps. And then you have your resource Minecraft block which takes all of the above and make the blocks for us. It will take the values from the list of blocks for each of the coordinates in this case. And then in our variables, we define width and length. We have defaults 10 and 1. So I probably expect, yep, the very next step will be to apply that configuration. Yeah. Sorry, I wrote that some time ago and I don't remember each step, but usually it is what I actually think. So if I'm going to go with Terraform applied now, I would expect that, oh, actually we can have a look on our map if the line is in the other way. I'm going to refresh it now. Yeah, so our line is now horizontal, not vertical. And we're going to take that configuration again. And this time we're going to define it in a slightly more DevOpsy way. And we would expect the 10 blocks to be created. Again, we're going to go horizontal, vertical, sorry. Other way than we are right now. I'm going to follow it with the rendering command, hoping that it will show us something very soon. Cool. So I'm going to give it a sec. Oh, there you go. Yeah, very unreliable, sometimes 5 minutes, sometimes 5 seconds. So we got our line built on the, to the different side. And that brings us to the point, okay, so we played a little with the resources. We started with making a block. And now all of a sudden we got a situation when our configuration is capable of making the shapes of a certain width and length. So you could make a rectangle out of it, make a square, and all you need to do is provide 2 numbers to get one. That sounds for me like something I would, as a Minecraft builder, I would use in the future. I mean, rectangles, lines, the possibilities are endless. So usually when we get to the point when, okay, I actually wrote something useful, that might be a particular configuration of your resource. You might be in the organization with rigid compliance and security rules, and you can only deploy the resources if they meet certain criteria. Or it might be that you build a web server with the database and everything, all bells and whistles, and all you need to provide to that website is the name of it. You would call them, in this case, if you have a solution encapsulated in the module, you would call them stack modules. And you can also have the resource modules when you have the particular configuration of the resource meeting certain standards and available for other people to use. So what we're going to do out of this configuration, we're going to make a Terraform module out of it. While I mention what the modules are, we're going to start making a local module. So there are 3 commands here which we need to execute before we're going to go for it. But actually, I missed one. We created a lot of stuff, but we haven't destroyed anything. So Let's do that first. So this is our last state. Beautiful fence, 10 blocks to the right. I'm going to tear it down now. So yeah, Terraform to destroy the configuration, to get rid of all the resources which you have defined within that context. We're going to go for Terraform destroy. I'm going to say in a second why am I destroying it this time, not just changing stuff, because what we did before, we were just changing stuff. Terraform knew, okay, I don't need that anymore, I need this, and so on. Now I'm asking you to actually destroy stuff because we're going to use the module. And yeah, the first 3 commands we need to make to actually create the structure for this module will be, we're going to make a directory within our context. We're going to call it cubicle. Whenever I wrote that, I thought that was a good name. I'm going to copy the Terraform file, the terraform.tf file. I'm going to copy it because it's going to it needs to be where the module is and where the module is invoked, which will be the current context. And I'm going to move the main.tf and the variables.tf files to that directory. So if you just grab that and execute it in the Terraform x Minecraft directory, that should do everything that needs to be done. And we can verify it by going to the IDE. We should see those 3 files under the cubicle directory and 2 files here. What we're going to do next, we're going to basically do the same stuff, but just using the module. So we moved our main.tf file to the cubicle directory. So now I'm going to copy this part and I'm going to create a new main.tf file in my main directory. So Terraform x Minecraft. So main.tf, and in this case I'm going to paste it. What it does, it's just say I want to create a module, and I'm going to call it a line. Again, you can call it whatever you want as long as you use that name once. And I'm going to use the module which is stored locally in the .cubicle directory. To use a module, and this is mostly, you can, as Wale showed and as we're going to go through later on, you can use the modules stored locally, but you could use the modules from someone's GitHub because someone did a good work and you want to use it. Or you can use the modules from the Terraform registry, which has a lot of really, really well written stuff. So when you use the module, you need to run the Terraform init again, which I'm going to do now. I think in this case, if I'll look into the .terraform directory, we have something called modules. Don't know if that's visible. So because I initialize this configuration, Terraform say, okay, this guy is using a module. I need to see, do I need to download this module?
Initialize before the plan.
Yep, if we use the module, or if we use the configuration for the first time, or if we would, let's say, add the backend, we need to tell Terraform, okay, have a look. Do you need to download anything? Do you need to get any stuff? And if I'll go to that terraform.modules directory, I would expect there won't be really anything there apart from the reference. Yeah, there's just the JSON file there, which probably will tell me that that module is stored locally. But and we're going to get to that soon. If we're going to get the modules from any remote place, it will just download it to the context, and it will store that module there. I'll show that in a minute. Cool. So we initialized it, and I wanted to do the plan. Cool. We've done this, and okay, we haven't done that. Cool. So I'm going to run the Terraform plan now, just for the sake of it. And what you would expect that will happen. Our previous configuration was making a line 10 blocks to the right. I would expect that if I type Terraform properly, that's exactly what Terraform will try to do now. I'm going to sneeze first. Oh. So, fair enough, we've seen that line already. So I'm going to skip that. and I'm going to jazz up that local section a little. So what we were doing in this, maybe I'll show it here, and in the section when we have set product, we used range, but we used it in the simplest way possible. So we can only put a number, and it will always start from 0. I mean, not every Minecraft builder wants to start from the middle. I advise you to start from the middle because it renders the fastest. But you might want something in the corner and so on. So it's not only, you want to have the control over where you start or where you stop. And I also added the step, so you can, just an ideas for the last one, you can make a chessboard very easily if you do the step, if you missed every second block. Or some more complex structures. So the only part I changed here, I added to do my range, I added the variable start, stop, and step, as per documentation. I also added the variable for height, and I did the same for length. So I'm going to copy those 2 lines, go back to my main.tf file, and line 1 to 4, I'm going to replace it with the new stuff. So you should have start, stop, and step. And we need to also reflect all that with the variables we use. So I'm going to grab all that. But they are very similar. So I'm going to grab and just make sure that you're in the main TF within the module, because we're editing the module now. We can get rid of what we used to have as a width and length and add start, stop, and so on. We can leave the block material. Oh, sorry, I added it all. So hopefully at this point the variables look, you have the material, width, start, stop, step, height, and length, start, stop, step. At this point I set length stop, length step to 1 and start to 0, and then width start to 0, stop to 1, and step to 1. If I use this module as it is, what do you think I will make? So we provide starting at 0, finishing at 1, starting at 0, finishing at 1. Anyone has an idea? Well, let's see. So I updated the module, so I need to tell Terraform that you might want to have a look on this module. And let's have a go and see if I will run a plan. I would say we should have just the 1 cube in the middle as we had at the very beginning. So we're starting from 0. We only go up to 1, so we only have 1 number, and our step is 1. So that should look familiar. We're back to square 1. All that work, and we basically where we started. Well, I think we are a little further because now we have a bit more possibilities. So we got now that module which could go left, let's say, you can define the width, you can define the length, and you can define the height. What I'm going to do, I'm going to go back to my main.tf file, and I'm going to change the way I call that module. So what we used to, I'm going to close everything around. So what I'm looking for, main.tf in my main directory, this file. So we just used to tell it, okay, just take me the module, whatever it is there, I'm fine with it. But now I say no. I say, okay, you can take that module, I like it, but I want it to be to create me something of a certain size. And you can see it now, like the passing the variables. Okay, someone defined them in the module, someone put a default, but now I'm using someone else's work, and I say, but okay, you might be good at making dots, but I'm going to make a square out of it just by using those 2 variables. Okay, well, of course we could start that square somewhere else. We could make a step, so then we would have a bit of a chessboard. For now, I'm going to just make a square because we haven't done anything in some time. We're still on that ugly line. Cool. So I'm going to go again, Terraform init and Terraform apply. So any ideas what we should see after applying this module with? Sorry?
5 blocks?
So yeah, there will be a square 5 by 5 if I'm doing it right. It says it's willing to add 25 blocks, so that's a good sign. And I will say yes, and I will go for render flat shortly, hoping that it will appear. So let's go to my map. Oh, I'm still on the destroy on the map, so it might take a minute. I might ask. Well, I don't have to ask. This is magic. So this is the square, which actually is there, believe me or not. And on my view, you can't see it, but like we started with the dot. Now we got a line. I like where we're going, and I really like where we're going to be at the end of it. So cool. We got a square. As you probably noticed at this point, at the point when we were, let's say, changing this set product block, I also removed that -60, which was a default ground level, and allow the user to actually define that. And I was mentioning that the Terraform has different functions, meta arguments, and I think the count is another meta argument we can use. So we could use it with the resources or with the modules. But when we define count, we say, whatever I define in this block, I want to do it 5 times. If whatever configuration you're creating, for instance, you can't create 10 same S3 buckets. So if you don't have anything on the organization level to handle those prefix, you can use count.index, and then once the count changes, it will just pass it to the naming you're using in your configuration. So now I'm going to call this module a cube, and that might be a little suggestive. So I want to ask, what do you expect is going to happen here? But well, let's apply it quickly, and then I'm going to go over. I'm going to initialize it again. So changes to the way I treat the module, I'm going to initialize it, and I'm going to apply it very quickly. 125 blocks sounds very cubical to me, and I'm going to clear my terminal and then go back to what we are actually doing here. So we're going to use the same module, but this time we're going to use it 5 times, and every time I use that module, I want the next layer to be 1 up, 1 up, 1 up, and 1 up. And I wasn't really secretive about what we're going to do. We're going to have 5 squares stacked on the top of each other, and they are 5 by 5. So we should have a perfect cube once we apply that. And I'm going to have a look on the map again. By the way, don't worry too much if the stuff is not appearing right away. I'm going to also leave all those servers so you can play around and share how to make your own. So we're still on the square, I think, unless, well, I don't have a 3D view. Yeah, I think I'm still on the square. So I'm going to look towards James, and there you go, there's a cube. Someone interfere with that cube. Nope. Okay. Cool. Well, we got the cube though. Cool. So I'm going to move to the next part, where we're going to leverage stuff other people build rather than what we build. Do we need to do anything? No, not yet. So actually, let me do. So I'm going to quickly copy this block and add it to the main.tf and quickly apply it. What it's going to do, it's going to remove that cube and I'm going to initialize that and then apply it, and then I'm going to talk over what I've done and why. So Terraform init and Terraform apply, followed by yes. You can see that some serious structure is coming your way. Cool. It's built already, but I'll show it in a minute. And let's go over what happened here. So we defining a module called Minecraft Words. And this time, we're not going to use a local module. We're going to use the module from GitHub specifically. It's a module called Minecraft Alphabet. It might give you a suggestion of what's going to happen with this module. It takes the position, which will be the starting position of whatever you're building. It takes a material, and it takes a string. I mentioned it's slightly different behavior when we initialize modules which are remote. So I'm going to go through Terraform modules, and in this case we got Minecraft Word modules, and there you go. So if I go to that hidden directory Terraform created, now apart from that little reference file, I also have a directory called Minecraft Words, and you can see there's some stuff, examples, some git ignore, there's a readme, and there are some Terraform files there. What happened, the Terraform basically just downloaded the repository, and I mean, this is exactly the one which was downloaded, and I can go there and have a look what that Terraform downloaded for us. So this is a Minecraft Words module repository, which our colleague Masi kindly created for us. As I mentioned, the inputs and outputs are automatically here defined. I think you need to generate that, but it's an automated process. As long as you keep your variables, your outputs, your descriptions nice and tidy, I wouldn't say that you don't have to keep the documentation, you still do, but it makes it way easier and way more obvious on how to use the module. The documentation of this module maybe is not the greatest, but it is enough to figure out what you want to do. You can also have a look on the example, and that should show you actually what characters you can use in this module to actually create those little letters. So I did apply that module right away, without thinking. Generally, if you apply stuff from the internet, I would say think twice, but in this case, we kind of know what we're doing. I'm going to run a little render again and go to my map. And hopefully, oh, there you go. It's already there. So I used the module created for me, which takes just a string, and it will write stuff for me in the Minecraft Word. So I use the string hello pandas. You can use whatever string you want, and this is exactly why we're not going to stream your string, because you can use whatever string you want. I'm not suggesting anything. We had this session internally before, and we had some ambitious strings. So let's put it that way. So again, that's an external module, and the good thing about Terraform, and whatever you touch, like I mean, we found a Minecraft provider. We thought we will have to write it because it was a fun idea. Yeah, how we can show Terraform. We found the Minecraft module already there. If you think of something popular, AWS, Azure, well, Alibaba, whatever cloud provider, Kubernetes, Helm, they are already there. Most of the time, they are managed by the actual provider of the service. So AWS will manage or be involved in managing the modules for AWS resources, and so on. There will be some examples in Terraform of AWS solutions, for instance. So they do stick with the CloudFormation most of the time, but they do share also the way they call it blueprints in Terraform for the certain solutions. So it's not going to be just, oh, create the EC2 instance, but let's say, I don't know, Kubernetes cluster ready for you to configure. There is a lot of really good stuff there. It might be overwhelming and complicating sometimes. So it's not always the best way for you to go, because if you need to create something very simple, you might not need to have a module which takes every possible input and every possible argument for that resource. But I added the link to the registry. It's really useful and has a lot of stuff. I think I already did this part and this part, which is cool. So just to recap, we kind of halfway through, almost even further. We got a module we can build shapes with the steps. We got a module we can build letters. And I've got one more for you, and it's called, I'm going to call it Panda. So you can see what probably is coming. I'm going to again go to main.tf, edit that file, well, basically replace it with yet another module. You can see it's more or less in the same place. Same author, it was Masi who actually made that module for us. And I'm just going to go ahead and apply it. Oh, well, this is what happens when you don't run the Terraform init before. But the Terraform error handling, I would say 90% of the time, is pretty good. And it's usually just read what happens and act accordingly. Something Surface Desk would expect from the users, but never happens. So initialize that module, I'm going to apply it again. And just to point it out, I replaced the previous module with Minecraft words with the Panda. I didn't really destroy anything. I just initialized the module and ran apply. The Terraform knew right away, okay, whatever I did before, I don't have that in my new configuration, but I have it in my state. So I need to get rid of those. There's some new stuff to come as well. So it's going to add 109 resources and destroy 186, which that's how many blocks it takes to write hello pandas. I'm going to go ahead and say yes to that. And I'm going to quickly go for the rendering part, render flat, go. And see if we got lucky this time with the rendering. There you go, still some old stuff, but this is what our Panda module does. You can place multiple pandas in multiple places based on your initial position. See, I hope you can see where I'm going with all this. See, first module we created, we can modify, builds rectangles, cubes and stuff. Module building pandas, module writing letters. We got a few more. So I added them as an example. I'm not going to make them right away. There's some modules which Masi created. They might overlap slightly if in the one we created as our journey through variables, locals, and so on. There's a module which will make a cube. It takes position and dimensions. There's a module which will make a hollow cube, which takes position and dimensions. So they are slightly similar, a bit similar to what we created. I'm going to skip this part when I actually use them, or actually, well, yeah, I'm going to skip that because the result will be more or less like this. So hollow cube and the cube. What I actually wanted to show you is what happens when we actually take what we learned so far about building structures in Minecraft with Terraform and its functions to another level and build something a bit more complex. So the very, very last part of this session, when we wait for the pizza, will be for you to get creative. So learning taking what you learned so far and what you could build so far, I did add the link to the documentation as well, so if you can get something, well, if you don't know how to make a shape, there is probably a way in Terraform using its function. I added the list of materials as well. This is a funny one. Okay, so I added a list of material, but our, actually, hang on. Unfortunately, our corporate security doesn't allow me to see it, so. And my VPN is not there yet. Oh, there you go. Apologies for that. So there is a list of material as well. If you struggle to open it, let me know. I'll figure it out how to show it for you. Anything like a bit too funny, it might not appear, but like a standard blocks work pretty well. So you can get a bit more creative in terms of colors and shapes of what you're adding to your configuration. And what I would really like you to get, and this is an example we got from, again, our colleague Massey, who spent his evening to actually designing this beautiful structure. Here we got a castle, and I'm going to build that castle. Well, that's not what I wanted to copy. So I'm going to grab this big block of code. Oh, I got back to that. So I'm going to grab my castle, going to put it to main.tf, replacing everything else I had. It already has some set of locals and so on, and it uses the modules we talked about, the hollow or the hollow cube and the cube. And what I'm going to do now, I'm going to go. Oh, I got logged out. Okay, Minecraft 23. Cool. So just to see if I'm going to initialize it because there's multiple modules I'm using in a different way, and I'm going to go with Terraform apply without going with enter yet. So you can see that there's some serious thinking involved in this module. So this structure we're going to build has only 1,548 blocks. We're going to destroy the previously sitting there Panda. And it only uses Terraform functions and expressions to actually design the structure. So you can see that all we have is some dimensions in the locals, the material for the towers and the wall separately. And we use a math expression, floor, you probably familiar with it, just rounds down whatever is in the parentheses here. And yeah, some basic math expressions added to this configuration. And the moment I apply it, and before I'll click magic yes, I'll ask for my magic elf to show you what's actually going to happen. Because the moment I say yes, the castle will slowly arise block by block, and there is a rate limit for Terraform for creating those blocks. There will be a rate limit for the AWS API and so on. But this is the beautiful creation we are going to end up with tonight. And what I want to encourage you now, play around. I don't know, if you want to make the castle pink, that's cool. That will work. If you want to take any of the modules or we created for you or you created today, go ahead. Yeah, that's the kind of a final step of our lab. I'm happy to answer any questions if there are any. Yeah, any questions? No? I hope that makes sense to some degree. I was looking at you, but I didn't hear any questions on the way. It is extremely silly to manage Minecraft with Terraform, but it shows you that what Terraform actually is capable of. Give me something I can call, and I'll call it for you. you got the same syntax across the different cloud providers and so on. Again, it doesn't mean that the moment you learn Terraform, you're an expert for every cloud provider. It's a bit like if you get a professionally equipped garage, you're not a mechanic yet. You still need to know how to fix the car. But it gives you a consistent language across different cloud providers. I happen to work for a big organization when we have on-prem GCP, Azure, and AWS. It does come handy that we all use Terraform and we all apply the configuration in Terraform. I don't know ins and outs of the cloud providers and configurations. I don't work with every day, but I can get a pretty good idea of what is going on in this config, even if I don't know specifically the provider and so on. So yeah, it is a powerful tool and it integrates pretty well with the pipelines, or you got the Terraform Cloud, Terraform Enterprise, which is their paid solution to actually manage the executing of the code for you. Are there any questions? We're waiting for the pizza, so please.
I was a bit worried about the way you were diving into the main.tf file, moving and deleting things and moving things around the main.tf file, which is really an important file in Terraform itself. I've never, in my whole experience with Terraform, ever been diving in and out of the main.tf file, moving things around there, because it really can be disruptive for the whole module.
Yeah, so I know that approach might come across as a little chaotic, because I've got an hour and I wanted to show you that like Terraform is cool, and also there is this and this and that. I would expect, yes, like you got the point. If the standard development, I would expect that module, that cubicle module, would be developed probably at some point by someone, and then eventually invoked in the main.tf. But because it was a quick crash course, I kind of skipped and moved what I initially thought it will be, what initially was our whole config, to the module, just to show how the modules work. But yeah, I agree that developing the Terraform code, it will be a bit more gradual than fast-paced process. Yeah, I hope that answers what you mentioned.
Yeah. If you're going from cloud provider to a different cloud provider, how much do you have to change your Terraform file to get it run on?
All of it.
Oh, we have to change all of it?
I would say so, yeah, but, or a majority of it. So here we got like the Terraform will be made out of the resources, probably main.tf. So they will be made of resources and then modules. So if I go, let's say AWS Terraform docs, and have a look on what I can do with that provider. So I think I added that link to at some point in the documentation. So this will be the documentation for the provider of this version. You can find something similar for Minecraft, but it will have one section. And then if I go to, let's say, EC2 will be an example of, that's the VM Elastic Compute. EC2? Elastic Compute something. Cloud. Elastic Cloud Compute or whatever. Yeah, I wanted to find the instance. Sorry, I'm really bad at typing, but cool. There you go. So that's just a VM on AWS. The very basic example looks like this. You call it AWS instance. I suppose if you will have Azure, that will be whatever Azure calls it. Then each resource you create, and I'm going to scroll down a little further, will have something, argument reference. So this is what you can provide to the instance to configure it. Some of them will be optional, some of them will be mandatory. I would guess that if I would create the VM in Azure, they might have an associate public IP address option, but it might be called associate public, and so on and so forth. So I would say it might be completely different for a different cloud provider, because they all have their own marketing teams, and AWS will have those weird acronyms you can't remember. GCP will call them differently, and so on and so forth. The principles will be very similar. So if you go to Azure provider, it will look similar. And if you know in general like what the virtual machine is, I'm pretty confident that by a quick look on the docs, you can create it in Azure, GCP, and EC2. But there will be some rewriting involved. So that there is a sales pitch, multi-cloud. Yeah, you still need to manage them separately. You got the same syntax, but different resources. Cool. You could get the box from it.
So if we need to create a resource on for Amazon, and is asking for the ID. Do we go to Amazon AWS website to create that instance first and get the ID from there to be able to use it on Terraform?
So you can do both. So when I configured my provider, I gave it the password for the Minecraft. You can when you configure the provider for AWS, you would provide it with access and secret key. In most of the cases, and then you can use the Terraform to create the resources from scratch from you. It might be a case that you already have some resources. You might want to reference those resources or get the data about those resources. You can do that. Sorry. So you also have something called data blocks. So it's not resources, but sorry, that's data connect. Yep, sorry, data sources. Going for it. Cool. So what you could do if you know something about the existing resource, like for some reason someone else created it, or you manage those resources in a different way, but there might be multiple reasons for that. If you have any data about those resources and you need to know more. So let's say I know that I have an instance with the tag Patrick, and I want to know the IP of this instance and what security group that instance is in. So you can, in this cases, you can use the data blocks. So then, assuming that you passed in the credentials you passed to Terraform have access to see that resource, you can use that. Okay, find me the instance with the tag Patrick and tell me about it. And you might need it later on in your further configuration. Or also a good example would be you might have a configuration when you have multiple accounts across your organization, and for some reason you need to know the VPC endpoint service name on your networking account from your customer account. And you could get it by writing an email, but you can also use the data resources to get the information from the different workspaces, from the different states, or at different accounts you got access to.
Okay.
Does that answer the question? Or?
Yeah, so if we're meant to, my question was if we're meant to create it from scratch, maybe I just joined an organization and they asked me to do it using Terraform.
I would say, so I am in the organization when we use Terraform quite heavily. And I would say use it if you can. There might be some benefits of prototyping through the console and so on, but I generally say use Terraform from the beginning. You will avoid a lot of problems or some leftovers on the accounts. And of course, you can always nuke the Sandpit account, but it's easier because you got it in your code base. You know your state and so on. Sorry. But it's not allowed to, for instance, test something in the console and try to make it in Terraform. That's cool too. I would say it depends on the approach in your organization, on the style of your workload, of your workflow and so on. But you can kind of do both. You could create something in console and import it to Terraform. But I would say, from my experience, that would be too much of a hassle. I usually just resort to, okay, it's easier to do it with Terraform. Because, for instance, if you go through the console and AWS as an example, you go from 10,000 menus to usually to uncheck the stuff you don't really need. And if I create a resource for Terraform, that will be an example. I can just say, okay, this and that, and the rest will go as a default. So it probably will be quicker for me most of the time. Hope that makes sense.
Thank you.
Cool. Anything else? Anything? Oh, you can ask for the throwable mic, and I can hear you, and people can hear you. Sorry. You can throw it. It should be soft.
Right, let's see if there's no, good. Terraform is obviously very good for standing up and tearing down environments very quickly. And when you amend your configuration in main.tf, it will destroy and then recreate. Like if you want to change your EC2 instance and give it a larger instance type, the old one will be destroyed, the new one will be created. How would you go about, let's say you have infrastructure that needs to be persisted. You have an artisanally crafted EC2 instance that's been running for 5 years and no one is allowed to kill it because that will take something out. Do you have any way in Terraform of sort of marking a specific instance as like this one, don't touch it, just keep track of it, but make sure it doesn't get destroyed?
So, yeah, I would say short, yes. If you're running an instance in the cloud for 5 years, I would ask why. But I get it. I've been in this situation and I ask why multiple times, and it's because someone said and we can't touch it. That happens. You can manage your state, so you could keep it outside of your state if you don't want Terraform to know about it or touch it, for instance. Yeah, that would be probably if I absolutely don't want Terraform to know. So there is a Terraform state command, and you can manage the state. Again, would be very careful, because then you can end up with having resources which Terraform doesn't know about, and you end up with some manual tasks. But if there is something, yeah, I definitely don't want Terraform to touch it by accident. You can, for instance, remove it from the state temporarily, then bring it back. I think, and I will ask Wale, I think there is a flag you can skip the resource, or there used to be a life cycle, but I think they commissioned that one. So, yeah, I can't remember exactly what's the block, but I think there is also sorry?
I think lifecycle of do not destroy will do that.
Yeah.
For that particular
So I know
resource.
that lifecycle block was supported for everything. Now it's not supported for everything.
I think you can specify it for one particular resources. Like, if you want to destroy any other resource, but do not destroy this particular resource.
Cool.
That's
So
if that particular resource doesn't depend on other resources, it will not destroy.
A bit like local variables.
yeah, so yeah, another thing will be lifecycle. I think we had the usage of the lifecycle, like an interesting one. We had the hosted zones attached to the VPC. So for instance, we didn't want the VPC try to reattach the hosted zones. So we had this captured in the lifecycle block. But I remember it was a bit tricky with one of the updates that we had to change it. And yeah, it's been something ago. But short answer, yes, and there will be more than one way to do it. Cool. You can get the box back, I can read it. It's a good one.
Yeah, it's prevent destroy.
Yeah, well, so that would be...
Yeah, so if you accidentally destroy a resource, or you assume you're done using it, and then maybe a manager comes and says you still need that resource, is there any way of retrieving it?
So, just so I understand, let's say we ask Terraform to destroy the resource.
Yeah.
If the API call, like say, went to the to AWS in this case,
Yeah.
it's the same as if you would destroy it from the console. So the short answer would be it depends if you have some other controls in place. So like, I don't know, you destroy the EBS volume, but you had a snapshot. Well, there is a way back from that, or you have some backup policies. But generally, the Terraform destroying the resource has the same power as you destroying the resource from the console.
Okay.
That's not me. Cool. Any other questions? Anything from online? Nope. Okay. Okay. Well, I hope that was useful to some degree. If I'm gonna keep the servers for a little longer, so if you want to go back home and play around, go for it. I would say, I don't know if we got a budget for that, but if you build something cool, send it over. We'll think of something cool to reward that. I'm pretty sure we can organize something. I don't know what yet, but if you build something cool, send it over. We'll find a way to reward that. And like I said, I will leave those servers for a little longer. I can see that the pizza is about to be cut right now, so the part we actually came for will be in the kitchen. And yeah, feel free to stay around and ask anyone about anything DevOps, really. We try to be helpful and chatty. Yeah, and I hope you enjoyed it. Pizzas are there, and the rest you know. Thanks.